Hello everyone, welcome back to the lab, or should I say Dr. Evil's lair. Yeah, sorry about the scar. This episode is going to be a teardown video. I picked up this thing just here on eBay. I thought it'd be nice to do a bit of a teardown. I've not really been making much progress when it comes to the DPB, the Quantel, of late, so I thought, right, time for a teardown, let's have a break. So first off, I want to thank my patrons for all of their support. If I didn't have my patrons, I would not be here now doing teardowns and fixing Quantels and all that sort of good stuff. So if you want to be a patron, then the links will be in the video description. You'll have exclusive access to new videos. There's exclusive videos for patrons, and there's private areas on my Discord as well. Yeah, if you want to be a patron, links are in the video description. This episode of DextersTechLab is also supported by PCBWay. This episode of DextersTechLab is sponsored by PCBWay. I've used PCBWay for projects here on the channel, so I know they offer awesome value and service for all your PCB prototype and production needs. Not forgetting their CNC and 3D printing services. Of course, in the run-up to Christmas, they have a huge selection of vouchers and offers available to make use of for the next 17 days. Links to PCBWay will be in the video description. Go and check them out. So what are we going to tear down today? It is this thing just here, and it's a barcode scanner. And you think, oh, it's not really that interesting, is it? But it's quite big. Yeah, this is one massive industrial barcode scanner, which popped up on my eBay radar, and so I picked it up. It wasn't expensive, only 20 quid, so I thought I'd give it a go. So I'm going to lug this onto the table and we will take a closer look. So this is a rather large barcode scanner. This seems to be intended for use in a large conveyor belt type situation where you have lots of boxes moving along a conveyor belt, and this would be installed on a large gantry above the conveyor belt, which then scans downwards and reads the barcodes from quite a distance, which is why it's so big. All the connections are on the front panel here, if you can call it a front panel. We've got the mains input with a nice securing brackety thing, and we have the ports that control it. It's manufactured by Datalogic. It is a DX8200-2100 to be specific. It seems to be made in Italy, so hi to all my Italian viewers. This seems to have been manufactured in 2002, so it is 20 years old. So that's obviously why it's popping up on the recycling sites. So the connections on the front here, we've got these are fairly logical things. We've got main interface, that's probably an RS-232 port. Output signals, there's probably some switch outputs to say I've read a barcode correctly or something like that. We've got auxiliary inputs on A and B, so they're we've got this port here reserved. I suspect that is a diagnostics port. I do have some user guides to, not this specific one, but very, very similar products in the range, and they do have RS-232 serial diagnostics. We've got another connector there, main interface and input-output signals. So I'm not sure what that is different to these. I don't know. We've got a number of status lights here, power on, external trigger, I mentioned that before, encoder, not sure what that means, good read, well that's pretty straightforward, so if that comes on then it's obviously read a barcode. TX data is obviously transmitting that barcode data to whatever goes on to receive it and process and make decisions on that. And we've got a network light as well, so I'm not quite sure how the network works with this because there's no RJ45s that I can see. Maybe we'll learn a little bit when we take this apart. Right, in terms of construction, it's very heavy. It's about 15 kilos, I would say. It's a fairly beefy bit of kit. It's all big sheets of I think they're aluminium. I think they're aluminium sheets, and there's some aluminium extrusions down the side, which everything just screws onto. There's nothing on any of the other sides apart from the base, which is where the laser comes out to read the barcodes. We can see two large windows where the laser would come out and scan downwards. So while I'm undoing these screws, we can talk a little bit about what is going to be going on in here. So there's going to be a laser source because it's a barcode scanner. It uses a laser. There is a warning sign on here saying it's a 1 milliwatt laser, so it's pretty low power. Obviously you don't need much to read barcodes. There's going to be spinning mirrors to reflect the laser down onto the packages or whatever it is that's intended to be scanned. Oh, that's interesting, taking that first screw out, it's actually a self-tapper. I was expecting to be nice threaded machine screws. And there's going to be a control board, of course, so but it'd be interesting to see how complex or simple this actually is. Oh, it's still stuck down. There we go. Right, I think what I'll do, these are just covers, then it's not going to help if I remove those. So I think I'm going to flip it over and remove the one on the base and see what's in there, and then I can show you what I'm seeing. So let's take this off. So I suspect in here we are going to find some of the control hardware. So quite clearly this gives us access to the control boards. Can't really see what's what just yet, but there is a board that carries the connections there, which plugs in with connectors just on there. It smells lovely. It definitely smells of old electronics. Maybe a little bit burnt though. So that board extends under there a little way, not by much though, so it probably comes to about here. But yeah, quite clearly there's some power coming in, there's power regulation, some switch mode power supplies I would suspect, and then these boards here which are all mounted on like mezzanine boards. Okay, what I just did is stop filming, and it's actually the next day, so we're going to carry on looking at this. I wanted to stop because I had to go off and do a few things, so I also took the opportunity to have a quick read through some of the user guides. As I said before, these are not the right ones for this model, but they seem to be from a similar range, so hopefully it might give us a bit of information. Another thing I've done is I've removed all the screws from the top and bottom covers just so we can get a really good look around this. So as you can see, we can now just remove the cover and we can see the optical bit on here. The other electronics are on the base, so if I just flip over, we've got all the electronics which we could only see through those little access covers, so got much better access now. So overall we have a very, very large base plate in the centre, and then these two extruded bits of aluminium on the outside. So the top and bottom covers don't really form any part of the structure, they're literally just covers. So yeah, really big plate there. That is probably prefabulated amylite. We've got the main boards here. These look like power supply, power regulation, that kind of thing. We've got a bunch of cards just here. So we've got 1, 2, 3. Doesn't look like there's much on that top one. That are obviously doing all of the digital electronic-y stuff. We've got a chassis power supply tucked in there. Presumably that's probably 12 volts coming in there at a guess. There's a small board in the back which just houses the connectors and all that sort of stuff, the LEDs. We've got a ribbon cable running over to this board which sticks out at the bottom. So I'm not 100%. There's actually an interposer board, so it comes on through this ribbon cable onto this board, which then plugs onto this one. So they've obviously added that on for some reason. I can't see if there's anything on it just yet, but it looks like that is literally just to bring the connections out to a convenient place just here. The connections for that disappear through onto the other side, and then right in the middle we've got this bracket with a small board on it, with what I think is SMA, with a coax running through to the other side. Now, when I was reading up in the user guide, it did mention that it uses an avalanche photodiode. So given that there is a little electrical warning sticker on the back, you probably can't see. Sorry, I didn't have it quite zoomed in. So you can see on the back of this board here, we've got a little electrical warning sign. If I recall, avalanche photodiodes do actually run at quite high voltage. Isn't it something like 90 volts or something? So that's probably why that's on there, and that is probably going to be the actual photodiode. And over here we've got a 4-wire connection going to the motor which drives the rotating mirror. So I'll show you that in a second once I flip it over. So now we can see the optical side. We have the rotating mirror just there. Interestingly, there is actually, oh, I see. The other connection on the other side is for the motor, and then this is some kind of sensor assembly. It looks like there's notches in an encoder wheel which is attached to the top of it, so it's obviously monitoring the rotational position of the mirror. So we've got a few mirrors arranged here, and so we've got 2 main mirrors which will bounce the laser out of the box. We've got 2 concaved mirrors just here, which look like they are pointing towards the photodiode. Just here, we've got a mirror here, here, and it looks like we've got 2 laser modules here. So I'm not quite sure what is going on. So if we take a closer look at the laser modules, they do look identical. They're mounted 90 degrees to each other. There's a mirror just here. But interesting, that's this mirror here is actually smaller than the mirror over here. Yeah, I've just adjusted the camera so you can see. So this mirror here is not as tall as this mirror here. So I'm not entirely sure what's going on. I might, when we power this on and hopefully the lasers come on, we might be able to sort of see a little bit better what's actually going on. So going back to the laser modules, they're all really nicely mounted onto this base plate. Lots of adjustment for position and angle, that kind of thing. We've got 4 wires which connect to this little board. They're the same on both of them. This one has, interestingly, a little extension cable. 1, 2, 3, 4 connections there, but only 2 are used. So possibly you can have another 2 lasers running off this board, and I'm not sure what these other connectors are for. So I wonder whether this might have been used in another product and it's been repurposed for this one. We've also got that connection which runs over to the optical encoders on the rotating mirror. So if we take a look at the rotating mirror, we can see it's just a 4-sided mirror just in there. I'm not going to touch it because I've put my fingerprints on it. And there's the encoder wheel on the top, so there's a large notch just there, and then these ones are smaller. We can see there the front of the photodiode. There looks to be some kind of filter in front of it, so that might well be very tuned to the same frequency as the lasers to stop any other ambient light getting in and spoiling the signal back. Right, I'm actually going to power this on. Now the switch that was for the laser and motor control, that is in the off position, so this should just turn on. Nice loud beep. I saw some lights flash. So it just says power on. Fine. So there's nothing coming out of the lasers yet. So let's turn this on. All right, okay, we do have laser light, and God, that mirror's shifting some, I tell you. I actually feel a little bit nervous being here. But yeah, that's certainly on. Right, okay, let me probably need to turn the light out so I can see the lasers, because it's not very bright at all. Give me a minute. Right, so I've got this running, and currently on my ceiling is a crosshair generated by the lasers. That is quite interesting. Now, I've been playing around with this and there's some funky stuff going on. I don't understand it. So we've got two lasers, but if I put my finger in front of either one of the lasers, the whole thing goes out. So when I block one, it switches off the other laser, which is interesting. Also, the lasers seem to be at different positions, and it seems to be able to adjust the power of the two lasers and sort of switch between them. It's all a bit confusing. I'm going to reposition the camera and I'll see if I can show you in obviously complete darkness, which we'll see. Right, as you can see, I've got this running still. So we've got one beam coming up here and another one here. So those are the two beams that come out. The two lasers are just here. So if I just show you if I just put this bit of paper in front, hopefully you can see two red dots on there. And yeah, did you see it switch then? So depending on how I interrupt these, it switches the power between the two, and they're slightly in different positions, which is kind of interesting. Yeah, if I block this one, there is actually still laser light getting through to here, but the crosshair goes off completely. And if I do the same on this one, it does. So there's something funky going on. I don't really understand it. Right, I've just been having a quick play around with this, looking at various different things. Now, the camera angle that you're seeing at the moment is looking onto one of the angled mirrors which bounces the laser out of the box. So you're effectively looking into the laser output. Now in front you can see two blue-green squares. Now they are the two mirrors which bounce the received laser back to the photodiode. So if I just put a bit of paper in front, there we go. There. So that's just going in front of those two mirrors. Now right in between them you can see the actual laser. Now if I just have to be very gentle on the moving the mirror around here, and it doesn't want to stay exactly where I want it. Let's try it. Let's try another position. It always wants to just sort of go slightly out of position, so I'm probably going to have to hold it. So there, right in the middle, between those two mirrors, you can see the output windows of the actual laser diodes. Now, if I put a piece of paper in front of one of them, you can see it only covers up half of it. So what's actually happening here is they're combining the two lasers half and half. So if I take the paper out of the way and move it in front of the other one, it blocks up the other half. So yeah, there's definitely something funky going on with these two lasers. Yeah, and of course if I put the paper in between of the path after they're combined, it covers both of them of course. So one laser, second laser, both lasers. So yeah. So if anybody knows what's going on here, I'd be interested to know, because I'm not really that good when it comes to optics like this. Okay, that was all really kind of interesting. Let's take a look at the actual control boards next. Yeah, there's not much going on there. So that's just a little board for doing the LED status lights. This one, don't know, can't really tell at this point. There's a relay just there, some dip switches, jumper settings. So this board has a bit more going on here. So we've got a Xilinx XC3042. We've got a program part there, so that's obviously the actual code that's stored in the machine. We've got an AMD AM85C30. This is an NEC 7028. Sorry, 70208 HGF-16. So that sounds like a little bit of a microprocessor or something. Got a Toshiba part there, TC55100 and one CF-70. So that's probably RAM for the microcontroller, and a few other bits and bobs. So yeah, there's so that's quite interesting. Connected by these two mezzanine connectors. Interesting, on this layer we are starting to see a bit more sort of raw logic going on. We've got some IDT parts, quite common for just doing mathematical, logic number crunching, and there's an Altera Max EPM 71288A TC100-10. So that's a CPLD. Actually, I think aren't they an SRAM CPLD? Because I think Quantel used some of those. So let's see if there's anything underneath there. So this one isn't screwed down. Oh, it might be actually. There's one just. No, don't think so. So I think we've just got binding we've just got standoffs here to remove. And there's a little bit more. There's some big heavy lifting going on. So we've got some more memory. That is IS4ILV16100-50T. I'm not sure what that is. When I find out, I shall put a link on the screen. And the large IC is an Intel strong arm, and the exact model number is Fades 11, whatever that is. So that's obviously an ARM-based CPU. Looks like there's a flash memory that's been programmed there, so that's probably the code for that. I'm not quite sure what barcodes this can actually read. So that's left us with the board on the base plate, with just the connections that go over to the rear panel. So yeah, there's not a lot in there, to be honest, as I kind of suspected. So yeah, really interesting device. Now, I'm not actually going to do a full tear down and take everything to bits, because I'm actually kind of tempted to have a play with this again in the future. So I think what I'm going to do is call it quits here. I'm going to put the covers back on. I might squirrel it away out in the shed, and we'll see if it becomes a future project. I've tried putting barcodes and stuff in front of it, and nothing seems to actually activate it. It doesn't seem to do anything more than turn the lasers on, make that crosshair. So yeah, I don't know, but I don't really want to take it to bits. completely. I think I just want to have another look at it later. So I hope you enjoyed this one. If you've got any information about what's actually going on optically in here, then I would be delighted to hear about it in the video comments, or if you want to join my Discord, any of that sort of stuff. Links to that, as always, is in the video description. So thank you very, very much for watching. Thanks to my patrons. I will see you on the next video. Bye for now.